Okay, today we have three virtually identical boards from Treadmill, from three different treadmills, that is, all from one treadmill replacement boards. And I have to diagnose actually the fault on them. Funny thing, they have three different date stamps, but one of them differs slightly. The oldest one differs slightly. I'll show you what's the difference between them. Here it is. Yes, you just try to find this spot. You see, this spot here, that's what I'm talking about. It's just the jumper here in those two pairs connecting. This is on two newer boards from 2015, while from 2014 board, instead it has this contraption of some sort. I don't know if somebody tried to fix it or what they did. That looks like a transistor, that of course capacitor here. Why would they do this? I have no idea. Apart from that, this board also has on the other side, this board has, was it on this side or, oh yeah, this reset button, while the other ones have not. You see, it's just, stuff here. Other than that, everything is virtually the same. Those capacitors look a little bit bulgy. I'll try to test them. In comparison with those, they look flat. Those look a little bit bulgy. I'll see what happens with it. Now, obviously, they changed the glue between 2014, which is this one, and 2015, which is this one. But apart from that, those boards are identical. So I'm trying to find the fault with them. I can't find on visual inspection of each one of them. I can't find anything wrong on the face of it. With the tiny exception of this contraption here, which appears to be on this board, the oldest one. But not on the newer ones. That looks to me like at least an afterthought if it was done in a factory. Suggests, I mean, the presence of this brown glue suggests to me that it was done in a factory. By the transistor. The capacitor next. The capacitor is for smoothing out the signal, I guess. And the transistor is for switching. Other switching. The idea because here is just a jumper, zero ohms jumper between those 2 points. And everything else looks identical. So I have no idea why they installed this very ugly contraption here. Nevertheless, what I'm trying to do now is to hook up some voltage to this board. Fortunately, I mean, I have no idea, I have no schematic, of course. Fortunately, they marked on the board power in, as you can see. And all those 3 pins, they attach to the big ground here. And all those 3 pins, which are connected, are touching to this big trace here. So my understanding would be that this one would be the minus and this one would be the plus. Since I have no idea what voltage comes in, I'll try with the smallest one first and see what happens if we have a short line or whatever. Now, to do that, it would be pretty hard. I don't have any plug. Well, I might have it, but I don't want to fiddle with it. So what I'll do, I'll just solder, since they are all connected together, all those 3 are connected together. All those 3 are connected together. Now, also what I'll do, I'll just double check which one is ground. I assume this one here is ground. So maybe, yep, this one is ground, as you can see. Shorting it off, like testing for continuity with the ground here. It's not ground, it's not. So what I'm going to do, I'm going to solder quickly, helping wires so I can connect my otherwise be crocodile clips to it. And then pump in some voltage and current into it. Okay, so what we have to is just like that. Now, those 3 legs are connected together for actually using because they are supposed to take bigger current. So just to make sure, solder them symmetrically. Because those 3 legs. Yeah, another giveaway that somewhere close by is the input, even if the input wasn't marked like power in here, would be that actually very close to this connector is the fuse. And the fuse goes from plus to somewhere further down the line on the positive side. So the fuse is the next thing after the input, which makes sense. Okay, so I'll just simply solve it. jump to selects. So solid plus. Positive. I'll do similar thing for the negative. Using old legs for capacitors and other through-hole components. I always handy. Okay. So flux here. My tweezers rather than bare hands, bare fingers. And too long. Okay. So taking my desktop power supply. This one is positive. This one is negative. So I hooked up that board to my desktop power supply. Started with 5 volts, nothing. Came up to 6 volts input. And it takes 670 milliamps. Both LEDs lit up. So you can see this one here lit up first, and then after second, this one here. So the board booted up. And I'm testing now for the outputs. And this is one connector which I started. And on this connector is 3.2 volts on this pin output. And nothing on the other ones. Nothing to speak of. Okay, we're testing the next connector. 4.7 volts on the first pin. 4.7 volts on the second pin. 0.8 volts on the third. 0.65 on the fourth. And nothing on the sixth. Okay, so this one, nothing, 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 nothing. Maybe just input. Okay, well, we have those pins here. Just do it from this side. Nothing, 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 nothing. It's 4.3 volts. 4.3 volts. 4.7 volts. and 4.7 volts. Is what seems to be all right. Obviously, I have no idea what outputs they should be, but at least this board is alive. 4.3 and some logical, sensible outputs. 4.3, 4.3, nothing, nothing, nothing. That looks like logical output. 3 pins on the plus and 3 on the minus. Well, let's try with this. 4.3, 5 volts, nothing, nothing, nothing. 0.1, that's nothing. 0.1, that's maybe just a signal. Nothing, nothing. Okay, those are done. Next. One, some of that. Think one. Nothing. But it's also logical. Let's try this one. Nothing. 3.3, that's okay. 3.3, 3.3. Nothing, nothing, nothing. 1.1, that seems to be also logical. 1.6, 3, 3.3. LED turned off. 3.3 still here. I think. 3. Six. Nothing. Okay, just let's reset it. This is the reset button. Nothing happens. Nothing happens. Okay, we'll turn it off. Can turn it on again and observe. The other LED turned on. It takes again 0.6. And this board seems to be fine. This board seems to be fine. I mean, all right, so some functionality may not work. I don't know, but 4.3 volts on MOSFET here, 5.9, 0. 4.2, 5.2 and 0. $2.2 is the power onto this chip. This one should be 0. And it is. $4.3 to this chip. Seems to be okay. I think this block works fine. Okay, we'll test the other. Yes, the processor works. I can feel the heatsink, pretty substantial heatsink with these two, with solid holding block. But I can feel it is warm, so the processor underneath works as well. No point removing it. Well, we'll see. I'll just unsolder it. A little contraption I made here for connection of my power supply. It's fine. It's fine. Clean it. Whatever mess I made. Flux. Some photos over here. Okay, mark this board as one. So this one is plus. And then it's minus. Let's mark it full. There we go. Solve the purpose. Lux. First 3. Last 3. Soldering iron. Shorten. Fine. Well, so right for that voltage and average. Okay. So just mark it to make sure I'm doing it right, so I don't make mistake. So this one is negative. This one is positive. Go to negative. Positive. Turn on the power supply. One LED lit up. As you can see, one LED lit up. The second LED lit up. And it's taking 600 milliamps, exactly as the other one. Okay, I'll test some voltages, compare them with the other board. Then we'll see. Round. And then we'll see in the third one, it was 3 point something. And it is 3.2, so that's fine. Here, it should be 4.8. It is 4.8. It is 0 from memory. 0.6. 0.6, that seems to be fine. 4.3, that seems to be fine. So it looks like this board is also alive. That is probably an input, although it had some 2 volts at the end. 4.3 volts at the end, so that seems to be all right. Two, 0. Again, this board looks fine to me. 3.2 here. 3.2, 3.3 here. Looks fine. And test it on last pin of this processor. This chip, 2.7, only 2.2. Just on the last one on this side. 4.3. Yeah, that all seems to be doing the same thing. There's this one. 4.2. This one was 5 point something. Yes, that's good. 4 point something. 4.3, yes. 5 point something. 5.1, yeah. All fine. All looks good. Can mark this one. Take away multi pins. And in it. And we'll see what happens underneath this block here. We solder that. Let's see what is going on here. Hey, why are you here? No idea. Put you aside to lose you. Plain space. Can we compare it with the other keyboards? Yes. Yeah. Somebody has modified that board here for some reason. And that doesn't look like exactly factory procedure. So what they did actually, they connected capacitor from this pad to the line. And also they connected the transistor from through the capacitor to the source. The gate was here and the drain was here. In the base. Okay, so if we join this part here with just a jumper or 0 ohm resistor, even this one looks good to me. To be, let's see. That's just perfect. I'll just lower it to small. Zero. I'll just stick here. So, flex. So this construction removed and made to the factory standard. See, that's the one difference in the board. See, the register is continuous. Yes, it is. By the way, I'll check if it is shorted to the ground. No, it's not. No, it's not. Good. Right, so if we now connect power, or actually I'll remove the other modification, not modification, the other difference. I'll remove this reset switch from here. Okay. So now it is, I think, identical to the other two boards. So when I connect it now, let's apply this. And turn on the thing. It still doesn't start. Check the fuse, choosing fuse. Fuse is fine. That one doesn't want to start. Okay. So what I may need to do, I may need to just increase the voltage to 9. It started to lit up this LED, and the other one started to lit up as well. Right. Okay, so I was told that it was more. 12 volts. As you can see, one LED shows on the screen, and the other two LEDs show here lit up. And 12 volts, it still takes. Well, let's see what voltage it gives out. This one. Shows 3.3. As on the other ones. And this one on 6, 5.2, 5.2. We're talking about 12 volts now. Previously, I was checking that only on the 6 volts. The heatsink is getting warm. I mean, lukewarm for now, but still warm. Cold. That shows some voltage, all right. Eight point 8 volts. 10 volts here. Oh, as you can see, perhaps those LEDs here show very finely. I'll try to remove, but you can still see that they lit up. This is the oldest board from 2014. Seems to work. Well, let's see. I think that the client said that this board was working off 14 volts. I got 14 volts now, only 467 milliamps. Well, it is a little bit brighter. Looks to me like all of those three boards are working just fine. Yep. Heatsink is warmish. It's definitely not cold, but it's not hot by all means. It's just warm to the touch. So processor must be working underneath. Hmm. Three. Right. So I let the client know, in my view, the boards are working fine, unless there is a specific problem with the output, of which I'm not sure. I don't know what that might be. Okay, we'll see what happens with the maps.